In this case, I am going to teach you on how to compute the mean for a discrete probability distribution. This is just a continuation on the previous one, no? So we have our x, our random variables, and it is the corresponding probability of each variables, no? This one is the formula for computing the mean. This is read as the mu. Mu is equal to the summation of x times p of x, or the mean is simply the summation of each random variable multiplied to its corresponding probability table, no? The first one, the second one, and the third column. 1 times 0.25, that is 0.25. So next one, 0.15 times 2, we have 5 times 2, that's 10, 3, 0, so we have here 0.30. Next, 0.10 or 0.1 times 3, we have here, what's this? 0 times 3, 0, 1 times 3, 3, and then 1, 2. We have still 0.30. Next, 0.30 times 4, so 0, 3 times 4, that is 12, 0, 1, so we have 1, 2, 1.20. Next, we have 0.20 times 5, this is 0, 2 times 5, this is, okay, 0, 2 times 5, this is 10, so 0, 1, 1, 0, 0. After getting the product of each random variable and its corresponding probability, we are now going to sum it all up, and that answer would be the mean, no? So 0.25, 0.30, 0.30, 1.20 plus 1, you add it, and then the sum would be the mean. The answer is 3.05. So that is the mean. In getting the mean, you only have to multiply the random variables to its corresponding probability, and then you add the products. That result would be the mean. Okay, so we move on to the variance and standard deviation. So after constructing a frequency table followed by computation of the probability of each random variable, we computed the mean, and then we have here the variance and the standard deviation. So we have two formulas here. This one, the sigma squared, this is for the variance, and the second one, the sigma, this is the standard deviation. So ang standard deviation, that is only the square root of the variance. So for you to be able to easily get the standard deviation, you have to get first the variance. So mag-start kita. We have here the values of our x, the p of x, since we will be needing this in getting the variance. Look at the formula. We have p of x here and x minus mu, or the random variables minus its corresponding mean. So pilay mean ka ganina, that is 3.05, no? 3.05, and we are also gonna add more table here, which is x minus mu squared, and then the last table, that is x minus mu squared times p of x. So here we go. Now we have here the values or the random variables, the probability for each corresponding variable, and then we have the random variable minus the mean. So ang mean nato kaina, that is 3.05. So 1 minus 3.05, that's negative 2.05. 2 minus 3.05, that is negative 1.05. 3 minus 3.05, that is negative 0.05. 4 minus 3.05, that is 0.95. and 5 minus 3.05, that is 1.95. Now the next step is to square this one. Square nato ang ilang difference. So negative 2.05 squared, or negative 2 0.05 times negative 2.05, that is 4.202. Negative 1.05 squared, or negative 1.05 times negative 1.05, that is 1.102. The rest will follow. So after getting this, we are now almost done to the final. We are now almost over to the final step, no? This is, from here, we are gonna multiply this to its corresponding probability. So 4.202 times 0.25, this is the product. Next, 1.102 times 0.15, this is the product. 0.002 times 0.1, we have this product. So tag-round off na ko ni, this is into 3 decimal form, no? Or 3 digits after the decimal form, and the rest will follow. So after making this table, after getting this one, we are going to add these digits, and the answer will be the variance. So try to add this. The sum is 2.245. You can check it using your calculators, no? So our variance here is 2.245. Now, in getting the standard deviation, dali ra ka na. Let us take the square root of 2. Sumpay ta, ha? No? The square root of 2.245, that is approximately 1.498. Okay, that's it.